A-level binomial expansion. Well, general binomial expansion to be specific, and you'll see why in a second. Check the comments to see the full question. We're just doing part A. So, we want to use the general binomial expansion to show that the square root of 1 plus 4x over 1 minus x is roughly equal to this thing here. The first problem we have is the form this is in. We have a fraction, so we're going to want to split it, and then we will work with it. So, firstly, this is equivalent to 1 plus 4x to the 0.5 over 1 minus x to the 0.5. So all I did there was said the square root of that over the square root of that, but then put it in indice form. We are then going to rewrite the new denominator as a power to a negative, such that we are left with this. Perfect. Now we can do the general binomial expansion. So let me get a different colored pen. I'm going to write it on the board because it is something you need to get into the habit of knowing. So 1 plus ax to the power n will give you 1 plus ax times n plus n minus 1 for 2 factorial ax squared plus n minus 1 n minus 2 over 3 factorial ax cubed. What I want to highlight to you is this term, and this term. Notice how they're in brackets. They're not just there to make it look cute. They have real life implications, and you'll see in a second. So, use your brackets, otherwise you will lose marks. So let's start off with this one. It is in the correct form. It is 1 plus or 1 minus x, so we can carry on. It needs to just always start off with a 1. So 1 plus 4x to the half will be 1 plus 4x times 0.5. I prefer using fractions, so I'm going to use fractions. If you want to use decimals, go for it, but it probably is harder, but it means you can put it in your calculator a little bit easily. And then we've got n, which is a half, n minus 1, which is negative a half, over 2, because 2 factorial is just 2 times 1. And then here, we've got 4x squared. If you write 4x squared, you're going to